Hello everyone. Today we will discuss about the most important topic in electric circuit theory, which is maze and nodal voltage analysis. Before DC network theorem, you have to know those voltage analysis method, because we have to calculate those method by KCL, KVL and those maze and nodal voltage analysis method. So this is for simplify the network, any electric network, and you can calculate either by applying KVL, KCL and either using those methods. So myself, Mr. Santanu Naskar, Assistant Professor of Electrical Department, GKCMJIS Group. My mail ID is santanu.uit@gmail.com and santanu.naskar_gkcm@jisgroup.org. And this is my Facebook page, Being Electrify with Santanu. You can get all the lectures here and as well as in my YouTube channel. So let's start. So here is your syllabus based on MACAUT electrical engineering. So your name of the course is electric circuit theory. Semester is third semester, that's means second year, and course code PCW301, and teaching scheme 3-hour lecture per week and 1-hour tutorial per week, and this is your practical 2-hour per week and credit point 4+1. As my previous video, I discussed about the objective of this course, and I also completed my lecture about introduction and coupled circuit and network theorem about formulation of network equation, source transformation, node, branch, and today we will discuss about nodal analysis and mesh analysis. So let's start. So what is mesh analysis? In circuit analysis, simple circuit can be analyzed by using basic analyzing tools like Ohm's law, KVL and KCL. But for a complex circuit that consists of various control sources, this tool in addition with series and parallel method are unreliable. Therefore, to find the variable of a branch in such circuit, nodal and mesh analysis method are used. By using this classical method, circuit variable like voltage and currents are easily determined in any branch without a great difficulty. Let us see the details about mesh analysis. So, mesh is a loop that doesn't consist of any other loop inside it. In my previous lecture, I have described what is mesh and what is loop and what is the difference between mesh and loop. Okay, so mesh analysis technique use mesh current as variables instead of current in it elements to analyze the circuit. Therefore, this method absolutely reduces the number of equations. Okay, to solve any circuit. So mesh analysis applies the Kirchhoff voltage law to determine the unknown current in a given circuit. Mesh analysis is also called as mesh current method or loop analysis. After finding the mesh current using KVL's, voltage anywhere in a given circuit can be determined by Ohm's law. So these are the basics thing which I will discuss in my video. So steps to analysis the mesh technique, an example problem or mesh analysis, and what is super mesh analysis, and example on super mesh analysis. So first we will go through the step. Please go through this picture and just listen my voice. So number one, check whether there is a possibility to transform all current source in a given circuit to voltage source. Assign the current direction to each mesh in a given circuit and follow the same direction for each mesh. Number 2. And number 3 is apply KVL to each mesh and simplify the KVL equation. Number 4 is solve the simultaneous equation of various methods to get the mesh current, and these equations are exactly equal to the number of meshes present in the network. So consider the DC circuit to apply the mesh current analysis such that current in different meshes can be found. In this figure there are 3 meshes, A, B, D, A. Okay, look here, A, B, D, A. Sorry, A, B, D, A, A, C, D, A, A, C, D, A. That means this and this. Mesh 1, mesh 2, mesh 3. Okay. So as a first step, the current through each mesh is assigned with the same direction as shown in the figure, and this is clockwise direction. Okay. Secondly, for each mesh we have to apply KVL. By applying KVL around the first loop, now go through this picture and remember, you have to remember the 4 rules which I have mentioned in my previous lecture. You have to remember this to calculate those meshes. Okay, so secondly, for each mesh we have to apply KVL. By applying KVL around the first loop, we get V1 minus V3 minus R2 within bracket I1 minus I3 minus R4 within bracket I1 minus I2 equals to 0. Okay, this, by this rule we can calculate those mesh. Very simple rule. Okay, now V1 minus V3 equals to I1 within bracket R2 plus R4 minus I2 R4 minus I3 R2, which is number 1 equation. Now second mesh, similarly by KVL, applying KVL around second mesh, V2 minus V2 minus R3 within bracket second mesh means this mesh, minus V2 minus R3 within bracket I2 minus I3 minus R4 within bracket I2 minus I1 equals to 0. That's mean minus V2 equals to minus I1 R4 plus I2 within bracket R3 plus R4 minus I3 R3 equals to, this is the number 2 equation. Now applying KVL third mesh. Okay, look here, starting from here, so this is positive V3, and after that minus R1 I3 here, then minus R3 I3 within bracket I3 minus I2 minus R2, which is also in common resistance in both mesh, R2 within bracket I3 minus I1 equals to 0. So we can write V3 equals to minus I1 R2 minus I2 R3 plus I3 within bracket R1 plus R2 plus R3, which is number 3 equation. Okay, so these are our mesh equation. Just simple, we are applying the simple KVL, and this rule you have to remember. If you know this rule and KVL, you can easily calculate those mesh, and nothing is complex in this mesh analysis. So now we will go through a example. So consider the below example in which we find the voltage across 12 ampere current source using mesh analysis. Okay, so in this given circuit all the sources are current source. Look here, all the sources are current source. So step 1, in the circuit there is a possibility to change the current source to a voltage source. On right hand side, source with parallel resistance, the current source is converted into a voltage source by placing the same value of resistor in series with a voltage source, and the voltage in that source is determined as like this: Vs equals to Is into Rs. So what is the value of Is? 4. And what is the value of Rs? 4. So this current and resistance become the voltage source. Look here, 4 ampere and 4 ohm resistance become 4 into 4, 16 volt voltage source, and resistance is 4 ohm. Okay, so very simple method. This is step 1. Now step 2, assign the branch current as I1 and I2 to the respective branches or loops and represent the direction of the current as shown below. Okay, now step 3 is applying the KVL to each mesh. Each mesh mean 2 mesh. Now mesh 1, Vx into, just go through this picture, Vx minus 6 into I1 minus I2 minus 18 equals to 0. Substituting I1 equals to I2 ampere, we can write Vx plus 6I2 equals to 90. This is equation 1. Now mesh 2, 18 minus 6 into I2 minus I1 within bracket minus 4 equals to minus 4 into I2 minus I2 minus 16 equals to 0. Okay, so from here we can calculate the value of current, which is 7.4 ampere. Now substituting the value in equation 1, we can get the value of Vx. So the value of Vx voltage is 45.6 volt. So it is very easy mathematics and very easy method if you understand the actual thing. Okay, now go through a next example. Consider the below circuit where we determine the voltage across the current source and a branch current ISC. Okay, assign the direction as shown below. So just nothing, just apply KVL. By applying KVL to the first mesh, we get V1 minus R2 within bracket I1 minus I3. Just look here, within bracket I1 minus I3 minus R4 I1 minus I2 equals to 0. Like this, we have to calculate the second mesh, number 2 equation, and third mesh, number 3 equation, and by solving 1 and 3 equation, the value of I1 we get, which is 4.46. okay, now therefore the voltage Vc equals to 4 into 4.46 plus 12 plus 2 into within bracket minus 0.615, okay, which is the value of I3. Just we are putting the value of I1 and I3. Now from here we can get the value of Vc, which is 28.61 volt, and the branch current ISC equals to I1 minus I3. So this I1 and I3 minus, that's mean I1 going through here and I3 going through here. So the motion is the in clockwise direction, so I1 is positive and I3 is opposite to the motion, so I3 is negative. So ISC equals to 5.075 ampere. Okay, Likewise, we can find every branch current using the mesh analysis. Now go through the super mesh analysis. Okay. So as we seen in the example 2, it is contains current source in one of its branch, and before the application of the mesh analysis to that circuit, we assume the unknown voltage across the current source and the mesh analysis is applied. This is quite difficult approach and it can be overcome by applying super mesh technique. So what is super mesh technique? A super mesh is formed when two adjacent meshes share a common current source. Okay. In the outer loop. Consider the circuit in which super mesh is formed by the loop around the current source. So the current source is common to the mesh 1 and mesh 2 and hence it must be analysis independently. To achieve this, assume the branch that contains current source is open circuited and create a new mesh called super mesh. Okay, so this is a super mesh. Now applying KVL to super mesh, we get V1 equals to I1R1 plus I2 minus I3R3 equals to I1R1 plus I2R3 minus I3R3 equals to 0. And the difference between two mesh current given the current from the current source, hence the current source direction is the loop current direction I1 and hence I1 is more than I2, then I equals to I1 minus I2. Thus by using this three mesh equation we can easily find the three unknown current in the network. Now go through an example of super mesh network. Okay. So consider the below example in which we have to find the current through the 10 ohm resistance. So nothing, just applying KVL mesh 1 we can get the equation 1, 11 I1 minus 10 I2 equals to 2. The mesh 2 and 3 consist of 4 ampere current source. Okay. So from here we can apply the super mesh technique. I equals to I3 minus I2, I3 minus I2 equals to 4. Okay, so 4 ampere, I3 minus I2 equals to 4 ampere because this I3 and this I2, the I3 going through like this and I2 going through like this. So I3 minus I2 equals to 4 ampere. Okay, now by applying KVL the outer loop of the super mesh, we get 10 I1 minus 15 I2 minus 15 I3 equals to 0. Now by solving 1, 2 and 3 we can get I1 equals to minus 2.35 ampere, I2 minus 2.78 ampere, I3 1.22 ampere. Okay, so hence the current through the 10 ohm resistance is I1 minus I2. Okay, so I1 and I2 both current going through this resistance, I1 like this and I2 like this. So I1 minus I2 which means minus 2.34 plus 2.78 which is 0.43 ampere. So this is mesh analysis and super mesh analysis. Okay, very easy. Now we will discuss about the nodal voltage analysis. So nodal voltage analysis finds the unknown voltage drop around a circuit between difference nodes that provide a common connection for two or more circuit components. So nodal voltage analysis complements the previous mesh analysis in that is equally powerful and based on the same concept of matrix analysis. As its name implies, nodal voltage analysis use the nodal equation of Kirchhoff's first law to find the voltage potential around the circuit. So by adding together all these nodal voltage, the net result will be equals to 0. Then if there are n node in the circuit, there will be n minus 1 independent nodal equation, and these alone are sufficient to describe and hence solve the circuit. At each node point, write down Kirchhoff's first law equation, that is the current entering a node are exactly equal in value to current leaving the node. Then express each current in terms of voltage across the branch. For n nodes, one node will be used as the reference node and all the other voltage will be reference or measured with respect to this common node. So for example, consider the circuit from the previous section. So consider this circuit. Okay, now in the above circuit, node D is chosen as the, please listen carefully, node D is chosen as the reference node and the other three nodes are assumed to have voltage VA, VB, VC. Okay, with respect to node D. Now for example, VA minus VB by 10 plus VC minus VB by 20 equals to VB by 40. So we can write as VA equals to 10 volt, VC equals to 20 volt. So VB can be easily find out. 1 minus V by 10 plus 1 minus V by 20 equals to VB by 40. So 2 equals to VB within bracket 1 by 40, 1 by 20, 1 by 10. So VB equals to 80 by 7 volt. So from here we can calculate the I3, which is 2 by 7 or 0.286 ampere. So again the same value of 0.286 ampere we found using Kirchhoff current law in the previous tutorial. From both mesh and nodal analysis method we have looked at so far, this is the simplest method of solving this particular circuit. Generally, nodal voltage analysis is more appropriate when there are a large number of current source around. The network is defined as I equals to YV, where I are the driving current source and V are the nodal voltage to be found. Y is the admittance matrix of the network which operates on voltage to give current. So these all are in matrix. Okay, now nodal voltage analysis summary. Now this is the summary, just nothing but the summary. The basic procedure for solving nodal analysis equation are: first of all, write down the current vector assuming current into a node are positive, like n into 1 matrix for n independent nodes. Number 2, write the admittance matrix matrix Y of the network, where Y11 the total admittance of the first node and Y22 the total admittance of the second node, and RJK the total admittance joining node J to node K. Okay, for a network with n independent nodes, Y will be an n into n matrix, and that Ynn will be positive and Yjk will be negative or 0 value. So the voltage vector will be n into L and will list the n voltage to be found. So this is nothing but the nodal voltage summary. So we have now seen that a number of theorem exist that simplify the analysis of linear circuit. Okay, in our next video or tutorial we will look at the different DC network theorem. Okay, so these are some reference of my lecture, Circuit Theory Analysis and Synthesis by Abhijit Chakraborty and Circuit and System by K.M. Soni. This is a very good book according to me. And Circuit Theory and Network S.P. Ghosh, A.K. Chakraborty. Okay, so these are some reference site, NPTEL video lectures, Electronics Hub, Electronics tutorial. So thank you, hope you all enjoy my lecture. So please stay safe and please like, comment, share and subscribe my channel. Thank you.